Hello everyone, welcome to the online module for Math 1200 for classes 6 and 7 to be completed between May 16th and May 23rd. I'm sorry that I can't be there in class within this next week, but I hope this online module will help you to learn a little bit more about conjectures and writing proofs. You'll have a chance to practice and collectively as a class review different proofs that you write, and then we'll reconnect on May 23rd to continue our investigations into proof writing. Also, don't forget that the TAs are available during our class time, from 2 to 3 that is, to answer any questions you have. So please feel free to reach out to them. It is completely optional, so long as you complete this online module, you will have fulfilled the requirements for this week in our class. So let's determine what you will be expected to do within this first half of the module. So by the end of this particular lesson, you will be able to use problem-solving techniques to make conjectures for properties of integers. So we'll look at even and odd integers in particular, a concept that we've been looking at and that you seem to be quite familiar with, to get a sense of how to make your own conjectures with more freedom, right? So you can consider any possibilities at all and be creative to explore the different facts to know about even and odd integers. And this will also give you a chance to explain why your conjectures hold. So we'll start to explore those proof methods that we talked about last week in class. You'll have a chance to try them out on concepts and properties of even and odd integers that shouldn't be too difficult to prove. All right, so before we get started into the activity I'm going to ask you to do as part of this module, let's take a moment to reflect on what we have accomplished in the course so far. So you have made at least 2 conjectures in our course using the problem-solving processes that we've talked about. So in the very first class, you made a conjecture based on the problem that was posed to you. In this particular conjecture, you were given a hypothesis, some condition to consider, and this allowed you to randomly choose examples to make your conjecture. And so each of you discovered that if x and y are any numbers, where x plus y is equal to 1, you concluded that your conjecture was that x squared plus y was equal to y squared plus x. And a number of you did this by trying a variety of random numbers that sum to 1 that satisfied that hypothesis, and were able to reach that conclusion and prove it through algebraic means. So something, again, that you are quite familiar with. Just last class, a new problem was posed to you that wasn't quite straightforward, right? So it was more open. You were asked to look at an equilateral triangle made up of smaller equilateral triangles inside, in particular one with 8 rows of these 1 by 1 by 1 equilateral triangles, and asked to count the number of triangles that you could see within that larger triangle. So you didn't have a specific hypothesis to help you to choose your examples in a particular way. If we were doing specialization, you were actually asked to count the number of triangles. If you counted and got a number, it could be quite difficult to identify a pattern just through the numbers that you have. And so what a lot of you did in order to come up with a conjecture, to make a generalization about a formula that would characterize the number of triangles within an n-fold triangle, for example, you had to be more systematic in how you counted those smaller triangles. Some of you counted them by breaking them down into their sizes, so figuring out a formula for counting the 1 by 1 triangles, and then considering 2 by 2 triangles, and then the 3 by 3 triangles. Others of you broke it down based on a particular vertex and counting the number of triangles that created that vertex and moving to different points within the larger triangle. Some of you split it even more, so not only by size, but also the orientation. So if the triangles were facing up, the top point was facing up or facing down. So there are a number of different strategies you used, and all work quite well, but you had to be more systematic. For one, to make sure that when you were counting, that you checked to make sure that you had covered all possible triangles, and then to ensure that it continued to work as you grew the triangle with more folds. So sometimes being more systematic in your specialization for trying out examples is necessary. Other times we don't have to try examples at all, and our conjectures come based on this process of generalizing. So analyzing to see what seems likely, why does it seem likely, and where it seems likely. So sometimes we have to add our own hypotheses to our conjecture in order to have a conjecture that we can prove. And this is something that mathematicians do all of the time. They're always looking for new problems and trying to solve new problems, ask questions, and looking to develop new mathematics based on exploring the answers to some of these problems. And sometimes we can't quite get the result that we want, and so we add different hypotheses to identify what we can prove. And so there's always this process of getting stuck and making breakthroughs by adding hypotheses and hopefully by taking them away. So as we explore properties of even integers, odd integers, or a combination of the two, you will have the freedom to add in whatever hypotheses you want to figure out what properties you can prove about even, odd, or both types of integers. You may have to check those observations that you're making, check using different examples or specializations, and you may have to reflect on the process that you went through to convince yourself that the property does hold before you can go to prove it. So our goal then is to generate some properties of even and odd integers and prove that property that you claim. And so in order to write a proof, we need to have clear, formal, accurate definitions of even and odd integers. So let's make sure we have a formal definition of even and odd integers.